thanks for joining me for this special edition as Israel is about to become just the fourth country to land a spacecraft on the moon. I'm Sarah Coates and we'll be bringing you all of the very latest on this historic event with correspondents stationed here in Israel and also in the United States. Now, it's the first craft that's been built privately, and if the mission is successful, will mark a new era in space research. One of the big challenges, though, will be, of course, the landing. It's all controlled via computer, and the craft will need to find and navigate its way down to a soft spot, avoiding craters and rocky outcrops on a part of the moon that's shielded from the sun's harshest rays, a manoeuvre which is being seen as one of the most difficult of the journey. And joining me here in the studio is Dr. Aviv Ophir, who's a Koshland Senior Postdoctoral Fellow from the Weizmann Institute of Science. Thank you so much for being here.
Good evening.
Tell us a little bit more about this mission.
Well, this mission was born out of the Google Lunar X Prize, which aimed at creating a private transportation network to the moon. Because currently the only ones who've ever been to the moon are countries, and Google wanted to private citizens, private companies to go there. And this is how this
yes, you've got something here to show us.
This is the result of one team, the Space IL team, of a version of how to go to the moon privately, which is very cheap in relative terms, just $100 million, but it really is cheap in relative terms. And this will be an example of how to get to the moon privately, and science is a subject here, but not the main one. Actually, getting there is the real issue.
Difficult part. All right, Aviv, we'll come back to you shortly, but for now, let's go to our senior international affairs correspondent, Owen Alterman, who is standing by at the observatory in Give It Time. Owen, thank you so much. You're watching this historic event unfold. What an incredible evening there. Tell us, what is the atmosphere like?
Well, Sarah, the atmosphere really is exciting. Everyone is excited to see Beresheet land on the moon. This is a family-oriented event. There are hundreds, if not thousands, of people here. You can see behind me the big screen, which in a short time will show the broadcast as we expect Beresheet to land on the moon. There have been telescopes set up for people to look at. What else? The moon. And also other activities for kids and for families. The kids are here. They're very excited. And let's actually hear from Karen Brand, one of the organizers of this event, and what she had to say and what this means to her and what this event is all about.
First of all, the significance is so great that every dream can be fulfilled. We are the fourth country that landed on the moon, and the three former powers were giant powers: China, the Soviet Union, and the United States of America. We are a small power, and the budgets for the project were small. When I was in the control room, I heard about the mishaps and, in fact, about the brilliant, creative solutions they found in comparison to the American teams at NASA and coping with a small budget. I am proud.
And Owen, thank you for that. We will come back to you there very shortly. But for now, Aviv, tell me, how long has this mission been underway now for, and what are the biggest dangers regarding tonight with this landing?
Well, from conception, it's been about 8 years, so it's quite a while, because it's been starting. They started by just having a very rough idea. The very first draft of the spacecraft was done literally on a napkin in a bar by the three founder engineers. And since then, they had to learn all the things that are involved in building a spacecraft, real spacecraft. And I don't know if you know the saying, but there is a saying that space is hard, and it really is hard. Building something that survives space is not trivial at all. You have to consider everything from fuel to orbit to not being too hot or too cold, to communication, to the science, to everything. And you have to make sure that everything works. Hopefully tonight we'll perform the landing, and the most difficult part of this landing is the landing software, actually, because there's no one to guide it. It's impossible to guide it from Earth. There's no human pilot.
So it's all via computer. Is that right?
autonomous driving.
Okay.
So because there is no pilot to pilot, there is no communication fast enough to allow a pilot to pilot it directly from Earth. It has to fly itself, and it has to navigate, and it will only aim roughly at a region where it is supposed to be relatively free of rocks or too steep slopes. But the actual slope, the actual terrain that it will get to is unknown.
That's right.
Therefore, it needs to autonomously navigate and find the correct spot, not too steep, not too rocky, so it won't topple over, and if it lands like that, it won't be any good.
That's right, and of course it would have been doing a lot of simulations, back here, etc. But, it hasn't been out in the field yet, so really anything could happen, couldn't it?
Indeed. You have to make your simulations as high fidelity as you can, but if you've missed something, this can kill you.
Okay, so what would happen, what sort of landing gear does this craft have, and if indeed it did, unfortunately, topple over, what next?
Well, it has its 4 legs, the landing gear, that were folded while launched, when it was launched, and were released shortly afterwards. And then it has an array of engines, of rocket engines around its perimeter, and the main one down here, that are supposed to decelerate it to landing and then aim it, because it needs to be at the correct orientation. And these are the main equipment for actually making maneuvers. But in order to decide which maneuvers to make, it has an array of cameras all around it to sense its environment, and the computer to make a sense of what it sees.
Okay, Viv, stay with me. We're going to go now to our correspondent, Ariel Waldman, who's in Yakud. Ariel, thank you. Tell us, you're there at the control room, I believe. What is it like in there? There must be so much tension.
The tension is virtually palpable. You can feel it in the air as the scientists wonder what exactly is going to happen next. You have to remember, there is not a certainty that this is going to land on the moon right now. The scientists are worried there could still be a problem. One of the heads of the program, Ofer Duroni, is the head of the space division here at Israel Aerospace Industries, came out and said there is a chance it goes wrong and slams right into the side of the moon. He said that even if that happens, though, it's still a triumph for Israel, because it would put Israel as one of only 7 nations to even make it to the moon in the first place, though the intent is still at 10:05 to land on the moon, making it the 4th nation to actually get something onto the lunar surface. Now, right now, just to give a little recap, the lunar lander is circling the moon at speeds of roughly 4,000 miles per hour. It's about to engage in some very complicated maneuvers as it drops about 1,500 feet of altitude per second and tries to slow down very rapidly so that it can touch down on the face of the moon in the Sea of Tranquility. Now, this all has to be done via a pre-programmed algorithm. There's no actual communication with the control room while it's doing this, because it's about 3.5 seconds each grand total for a transmission from Earth to get to that lander, which is about 250,000 miles from us right now, and then get back again. So very much has to be done by perfect programming, because if that's even the tiniest fraction of a second off, or if the coordinates are off slightly, and remember, over the past few weeks, there have been some problems with the location sensors on the lunar lander, then instead of landing on the moon, we could see Ofer Duroni's fears come true, and you have a crash landing. Now, right now, everyone is pretty confident you're not going to have any sort of crash. Remember, we did have some very complicated maneuvers just a week ago during the lunar capture period. That's when the lander was in Earth orbit, intersected with the moon, and was grabbed by the moon's gravity, bringing it into the series of smaller and smaller orbits until we get to today. So that went off without a hitch, and everyone's hoping that today follows suit.
They certainly are, Ariel. Thank you very much, and we will come back to you very shortly, but we are going out for a short break. When we come back, we'll keep following this historic event as Israel attempts a moon landing, set to become just the 4th country to do so. Stay with us.
I-24 News, the international channel in the heart of the Middle East, now brings you a new view of this troubled region. From I-24 News' acclaimed Arabic language channel, the stories, the people, the passions of the Middle East that you haven't seen before. A weekly roundup of highlights from I-24 News Arabic. Every Sunday, only on I-24 News.
Esta semana en News 24, elecciones 2019, ganó Netanyahu. Análisis y comentarios de los contendientes y cómo se vivió el día de las elecciones detrás de escena en los distintos partidos. Y también Bolsonaro en Israel, reuniones políticas, rondas de negocios y ceremonias llenas de simbolismo y con mucha emoción. News 24, el magazine semanal en español de I-24 News.
I'm Michelle McCory on I-24 News. Join me on Clear Cut, where we cut to the chase with a straightforward yet insightful breakdown of the world's top political and economic stories.
Weeknights beginning at 7 p.m. Eastern, only on I-24 News.
Welcome back to this special edition as Israel is about to become just the fourth country to land a spacecraft on the moon. We will be bringing you all of the very latest on this historic event with correspondents stationed here in Israel and in the United States. Now, it's the first craft that's been built privately, and if the mission is successful, will mark a new era in space research. One of the big challenges, though, will be, of course, the landing. It's all controlled via computer, and the craft will need to find and navigate its way down to a soft spot, avoiding craters and rocky outcrops on a part of the moon that's shielded from the scorching sun, a manoeuvre which is being seen as one of the most difficult of the journey. And joining me here in the studio is Dr. Aviv Afir, who's a Koshland Senior Postdoctoral Fellow from the Weizmann Institute of Science, and Aharon Lapidot, who's an aviation expert. Thank you both so much. Okay, so we've spoken about already, you know, the actual mission. Let's talk about now tonight. Will we see this in real time?
Well, that's this is why we gathered here. No, we're gonna see the photograph sent by the by Beresheet, by the spacecraft, and I think it will stir a lot of excitement here and everywhere else. I understand that Buzz Aldrin, who walked on the moon together with Neil Armstrong in '69, is watching this very, very closely and is excited as we are.
Yes, unfortunately, the connection speed is not like high-speed connection we're used to at our home. Therefore, the pictures that will arrive will not arrive simultaneously, immediately upon landing. We will initially hear just an announcement, we have landed, and then it will take some time until we actually get to see the pictures.
Okay, gentlemen, stay with me. Let's go now to our correspondent Ariel Levin-Waldman in Yehud, which is where the control room for this mission is. Ariel, thank you. Tell us, how far away now is this craft from actually, you know, reaching its destination?
We are down to about 25 minutes until landing. Remember, 10:05 p.m. Israel time. They have already started the procedures for that final descent onto the moon's surface. Now, right now, the craft is starting to decelerate. It is traveling about 4,000 miles per hour above the moon's surface and starting to lose speed and lose altitude. As it enters the next stage, it's going to start dropping at about 1,500 feet per second as it gets ready to to land its final part of the journey in the middle of the Sea of Tranquility. Now, that is a very complex maneuver that is very fraught with possible dangers, because any slight deviation from course and any slight miscalculation in the onboard computer on the Beresheet lander, that's the model I'm holding right now, the real one's about the size of a refrigerator, could mean that it slams into the side of the moon rather than landing on it. And I want to give you some breakdown directly from the source itself. So let's hear the words from Ofer Daron. He's the head of the space division at Israel's Aerospace Industries.
Very nervous, very excited, waiting to go. Sort of hoping that these 2 hours are over and we start the landing process and we go for it. There are very, very many risks in the landing phase. There are things that have never been done before. We're landing with a laser sensor that's never been done before. Many things can go wrong. So really, we hope that Beresheet will succeed in the landing.
Ariel, thank you. And you stay put there. We will come back to you very, very shortly. But, gentlemen, let's talk a little bit more about this mission. If it is indeed successful, what will we learn about the moon that we don't already know?
Well, this is a question that's been asked ever since the flights, the space flight started. And the actual answer is that it's such a plethora of benefits that the universe has gathered from the learning during these missions that includes everything, you know, from these blankets that you put on injured people that keep them safe, the golden blanket, to concentrated food, to, you know, whatever. There are a lot of things that we learn from this flight. Beresheet is a very modest, very modest mission. As we all know, it's the least expensive ever craft to reach the moon, and it has to, you know, at least it's a proof of ability of doing that. But I already heard that there are a few countries that are interested in this in a way that they want to build similar crafts.
Okay, gentlemen, stay with me. For now, let's go to our correspondent, Pierre Kloschendler, who is in Jerusalem, where there's a screening of this historic event. Pierre, there must be so much excitement there. Tell us, what are you hearing from all of those people behind you?
People behind me are invitees of the president, and today the president is the president of the children of Israel, because parents whose spouses are working at the Israeli NGO Space IL, which launched that spacecraft, that flying washing machine into space to land on the moon in about half an hour from now, these kids are here to live a dream come true for them. I remember I was a kid in 1969, 50 years ago, when Neil Armstrong stepped foot on the moon. And today, for those kids, it's the first time in their life. And of course, it's such an excitement. They've been waving flags, shouting, "Good luck, Beresheet, good luck, Genesis." And it's a great moment for them, of course. And today, the president has assembled them around him. He's supposed to arrive here in any moment, at any moment.
So, Pierre, do you think this will inspire a new generation of Israeli space research?
This is the goal, indeed. There are educational teams all around the country that have been organizing activities for kids in schools around the country. They've been building these space models, as you can see. They've been competing for the best video, for the best selfie of the spacecraft. And of course, it's supposed to inspire the new generation of future astronauts. Astronomy is, in a sense, the history of the origin of our world. And Genesis, in the beginning, Beresheet in Hebrew, is really trying with very little means to understand at least the history of our satellites, if and when the spacecraft will land on the moon. It will study the magnetic field of the moon, of the Earth satellites, and obviously trying to find a way to the scientific world in order to put a new stone on the scientific building, which is today immense. Just yesterday, there was the first picture of a black hole ever done, the first proof of a black hole. So we are living in an astronomic era, a revived astronomic era after many years of slowdown in this field of science.
We certainly are, Pierre Clochendler. Very exciting there. Stay with me. We'll come back to you a little later. But for now, we're joined on Skype by the chair of Harvard's Astronomy Department, Professor Avi Laib. But thank you so much for being with us. Tell us just how difficult is a project or a mission such as this?
Well, it's very difficult since only 3 nations were able to achieve this feat in the past, and Israel joins this very prestigious club. Moreover, Israel demonstrated with this mission that such a project, such a challenging task, can be accomplished with only $100 million. And, that's at least a factor of 5 less expensive than the typical mission of this type that the NASA launches, for example. So it's a demonstration that the private sector can do these missions much more cheaply than we have done in the past.
And Avi, tell me, just how difficult will the landing be, and what are the main dangers that this craft is facing?
Landing is non-trivial, and it took the United States a number of attempts before a successful landing was accomplished, because it's difficult to see the terrain on the surface of the moon from a large distance, and to navigate such that one would land softly. And so we shall see how Beresheet does. But overall, already arriving at this phase is a great accomplishment, and I'm sure that there would be many implications in the future for the design of lunar missions and even beyond the moon.
It certainly is a great accomplishment, and I understand that this craft will need to be recharged by the sun rays, but tell us just how close can it actually get to the sun without being burnt to a crisp?
Well, the moon is sufficiently far. I mean, the moon is roughly at the distance of the Earth from the sun, so there is no issue. The only difference from being on the Earth is that there is no atmosphere to the moon, so one is exposed to flares from the sun that could be quite damaging to electronics. But it's not as if the actual spacecraft will be burned up. It's just that it's vulnerable to energetic particles that can hit it and destroy the electronics.
Okay, and we know that this mission cost $100 million, but how much does it cost to actually build the craft itself?
Yeah, so in principle, one can save some money and produce such a mission at a cost that is a few times lower if one, has all the elements necessary and knows in advance the plan. It took several iterations for Beresheet to arrive at the current weight that it carried, the payload weight, and if one would have known it in advance, what the final payload would be and how heavy it would be and what the design it should have, then one could have saved some of the effort. So I think in the future, the private sector could design missions that are a bit less expensive. It's already a major milestone in terms of demonstrating that a privately funded project can achieve this, and also for Israel, as in terms of being one of the leading nations in the space frontier is a great accomplishment and a source of pride. And I think there are many reasons to think about space as the next frontier, and Israel being one of the leaders in that regard.
That is certainly right. All right, Avi, stay with me. We will come back to you a little later on in the broadcast, but we're coming back to the studio now. Gentlemen, tell us what happens to this spacecraft if it lands successfully. What then?
At that point, it will start taking health checks to see if it's landed healthily. And once this passes, it will take pictures of its surroundings and turn on its scientific instrument, the magnetometer, and try to use its stay there for its science mission, which is measuring the magnetic field of the moon. Importantly, this spacecraft was born out of the Google Lunar X Prize project, which is a prize competition by Google to actually get to the moon via private entities. And therefore, getting to the moon has been the main driver for the design of this spacecraft. So getting to the moon is the main thing, and the science experiment is a bonus. Once you have a design ready, as Professor Leib had said, you can use it many times. So, and you can build the second and third or 100th.
Bigger and better even.
And therefore, once it's proven to be working, this is a workhorse.
Certainly.
It was mentioned, passing by the laser sensor that is used for landing. This comes this replaces the radar, which is much more heavier, that was used in landings as this before, and they were trying to find something that is lighter, but it has been never tested before in real life. If it works, that's a huge leap in space technology, and this is just one of the major innovation that Beresheet brings to the world.
Okay, gentlemen, stay with me. Now, as Israel looks set to try and make history on the moon very shortly, 7 weeks after the Israeli spacecraft Beresheet soared off from Cape Canaveral in Florida, it's poised to reach the moon tonight. Only 3 countries have completed successful spacecraft landings on the lunar surface: the US, Russia, and China. Okay, gentlemen, all very exciting here tonight. Tell us, we know that the gravitation on the moon is 6 times weaker than here on Earth. So how will this affect the landing?
Well, for once, when it finally reaches low velocity, as it was said already, it is now moving very fast. So it needs to turn its engines to decelerate. And then it will decelerate and try to reach to 0 velocity and hover, but not on the moon's surface. Because if it gets too close, then the exhaust from the engines would
push it up again.
Push up dust and rocks, and would hurt the spacecraft. And therefore, it will shut down its engines 5 meters above the ground. Well, 5 meters sounds quite high for us, but 5 meters when you have 6th the gravity is not that high. So it will be equivalent to falling from a height of about 80 centimeters here, which is not very high at all.
Okay, so it wouldn't damage the landing equipment at all? It should be okay?
It's calibrated to withstand this, so it won't be landing as if it was falling from 5 meters here on Earth.
And tell us, what sort of engines do they use on a craft like this to get it up to such high speeds?
Rocket engines, because on Earth, what you need to travel at high speeds, for example, in airplanes, you have engine planes which take fuel from the fuel tank and air from the atmosphere. Rocket engines work in space where you don't have an atmosphere, so you have to have two tanks, one for fuel and one for oxygen. And here in this spacecraft, you have a number of tanks inside for fuel, for oxygen, and a number of rocket engines around the perimeter to allow it to steer in different directions.
This is how it's done with all spacecraft. They're using the same. What's more interesting about Beresheet is the launching and the way it traveled to the moon. It has a path which is completely original. I don't know. You can correct me if I'm wrong, but I don't think that any other spacecraft did this before, because what we saw here is using the gravity of the moon to pull the spacecraft to it, and that's a very, very tricky maneuver, getting released from the Earth's gravity and coming to the moon's gravity. And this is all to save fuel, to make it lighter, and to make it cheaper. And that's, I think, it's amazing, because it brings this type of mission closer to possible.
Well, certainly so many factors at play there, and of course one of those massive ones is, of course, the control room, and our correspondent Ariel Levin-Waldman is right there in the control room, rather in your hood. Ariel, not long now to go. Tell us, what is the feeling where you are?
Right now, we are just minutes away from initiating those final moments of the maneuver, slowing down the spacecraft and landing it on the surface of the moon. To talk about the feeling in the atmosphere, I could turn directly behind me where the Prime Minister of Israel is giving a speech, praising Israeli vision and Israeli technology for how far it has come. He is calling it right now a great achievement, putting Israel on the map with a small, select few nations that have made the trip beyond Earth's orbit into deep space. Only 7 nations to date have made it anywhere near the moon into lunar orbit, and only 3 so far have actually landed on the moon's surface. Right now, the hope is that in the next 5 minutes, Israel could become nation number 4, the first non-superpower to make it to the moon. Remember, the only other nations to land anything on the moon's surface was the United States.
Yes. All right, let's go now to Jerusalem, where Prime Minister Netanyahu is speaking.
And it just flew off to inconceivable spaces. I'm really considering seriously to invest now in a space program. A space program, it has implications, national implications for the state of Israel, and also implications for humanity at large, and we're going to do it. The Prime Minister spoke about kids and inspiration in the President's home. People are now viewing many kids who are so excited that they're watching. Let's go over there. You can see them here. Almost 200 kids went to visit the President, and he's going to talk to us soon as well. An amazing generation that is experiencing and enjoying. And now I'd like to, first of all, give you the credit before I give the floor. Dr. Ido Antebi, Director General of Space IL, Ofer Doron, the Director of IAI. These 2 people this evening are going to lead us hand in hand throughout this whole dramatic maneuver. First of all, you are our pride. They are our pride. Thank you very much. Come on. Good evening. As Moti said, we're going to try to accompany this landing process. We're going to explain it as it happens. And yes, we're very excited, we're very tense, and we hope we're going to make it. So the process of landing will actually begin at 10:08, or in another 2 minutes actually, and I'll try to explain the beginning in a few words. Our spacecraft is now hovering. We just see the picture, a picture that was taken about an hour ago when the spacecraft was at the height of 15 kilometers. You can see the area. The spacecraft will begin from the situation it's in at the moment. You can see its orientation on the screen. It'll start its movement, and at the first stage, in order to brake, it will turn, and it will turn its engines together with its movement. We have to brake the spacecraft at the speed of 6,000 kilometers an hour to zero. We're talking about 25-30 kilometers height and to go to zero height. And we have to brake the aircraft. We're talking about the landing supposed to stable itself, and the engines and the fuel. Because of the acceleration, the fuel turns towards the engines. That's why we have to do it. And this is the stage of the readiness of the spacecraft to the landing itself. At this point, this is not exactly the picture of the spacecraft, says his colleague. At this point, the spacecraft operates the main engine, is checking all the systems, and actually in the first 4 minutes of the maneuver, the spacecraft can make a decision. The control system can make a decision to stop the landing. If there's no such decision, actually we went over the no-return point, and then it's going to land. We're going to wait to the beginning of the maneuver. Tighten your seat belts.
A few words in English. We're about to start the landing process. We're going to orientate the spacecraft in the right direction so that the engines are pointing to brake us in our maneuver towards the moon. We're now about 850 kilometers from our landing site. We're at an altitude of 25 kilometers. We hope we've measured it correctly. We think we've done that to an accuracy of about 100 meters, which is amazing at the range we're at right now. And the whole process will take us about 21 minutes. And we're going to get into that in 15 seconds.
The spacecraft is autonomous. It measures the height and the velocity, and it estimates its distance. We are now in landing mode. You can see it on the right-hand side of the screen, and this is just the beginning. The engines are not working yet. We went over to orientation. We are directing the spacecraft, and we see the engines around it. These are the small engines that change the direction of the spacecraft. In the middle of those engines is the major engine. It's going to start, and we'll see it in a few minutes. In the meantime, we'll give you a short survey about the process we went into. You see, we are now in a landing mode. And as we said, this is the stage where the spacecraft is making all the necessary tests so that the control system will be convinced that it can actually land. We're talking about the calibration of our navigation tools vis-a-vis velocity and and other items. The moment this calibration ends and all the engines are checked, and the moment we get to the stage where the main engine is working, actually this is the point of no return, and this process takes about 3 to 4 minutes, and we're going to see it happening. We are now 30 kilometers high. Actually, we're on an ellipse, where the great distance of the ellipse is 200 kilometers, and the small one is 15 kilometers, and now actually we're taking advantage of the close area, and we are going to land with it.
The spacecraft, we've used the engines on the circumference of the spacecraft in order to get it in the right direction, and in about a minute or two we will start firing the main engine to start braking the spacecraft. We have a few seconds at the beginning of the process where the spacecraft will decide by itself if everything is okay. If not, it aborts the landing and continues in its orbit. If it decides everything is okay, we're in a non-return point. We're in the landing process. There's nothing more we can do. 1 minute to landing, דקה לירי.
If the spacecraft will, or the system will make a decision that it's going to abort the maneuver, it goes back to the orbit, and we have 4 hours to prepare ourselves for another attempt. And we're going to go into it if we understand what happened and why the spacecraft aborted itself. We'll enter the braking stage. You'll see the main engine, and on the right-hand side, where it says orientation, it'll say braking. Another few seconds, entry to braking. We are in braking. In the beginning, the small engines are working simultaneously in order to push the fuel. We passed the point of no return. The point of no return. The main engine is now in action, and now we go into a process of some 17 minutes where the spacecraft reduces its height about 6 degrees. It increases the angle to 30 degrees. You can see the action on this screen. You can see the height going down. Now it's 24 kilometers height. The velocity is reducing. Our main velocity is horizontal, and it's now reducing gradually. Those people who want it more engineered, you can see the velocity where it says acceleration X, Y, Z. This is the axis of the spacecraft. And now we're braking 1.6 meters per second. In any case, until now, everything is working very nicely, but we have to remember that this spacecraft never landed on the moon. We never actually checked the process of landing, and anything can happen. The main risks that we see in this process is, of course, the main engine stopping for some reason, and we just lose the whole process. We have a landing sensor, a very unique landing sensor. We only have one on this spacecraft. Our navigation control is the one that actually manages the whole autonomous spacecraft, and that's the one that actually drives it. And in software, as we know, we can have a bug. And obviously, you know the story of those people who follow stars. Here as well, the stars and the limitations of the stars. So we had to choose a very unique track.
So we are in the braking process. The braking process is working well. We can see the spacecraft slowing down. You can see the velocity as we are slowing down, and the spacecraft is doing exactly what it's supposed to do right now.
Height 21 kilometers.
The spacecraft is now pointing at about 15 degrees to the horizon. 15
degrees to the horizon, so our braking also goes gradually and also brakes us. Another data, we started our voyage to the moon with 420 kilos of fuel. And now we are on 200 kilos, and during the landing, 180 kilo fuels will be burned. We took more than a third of the fuel we took to the moon just for braking, just for landing. You can see now the battery. The battery is now charged 75%. Maybe a few words about the control room. The control room is manned by a joint team of the IAI and the Space IL.
דניאל, תמתין בבקשה פעם הבאה שאני אבקש ממך.
יש בצוות צעירים.
There are a group of young people, some of them are less young and others are very much less young. Some of them have decades of experience in space. Some of them are new in the business and they work as a joint team, a small group with a large group of young people and older people. They're all experts and they're divided. On the left, we have the engineers, Alex and Yoav. Behind them, diagonally, the controllers who speak to the spacecraft. All the others are just looking. The ones who actually send the orders to the spacecraft are these guys. All the others are great experts, each in his own field, and each of them are going to analyze their data. We are getting 5,000 different data. Every given moment, 400 data. And each of these engineers know the data. They did it in simulations and in exercises. We now got, and we'll see in a minute, the first picture from the actual landing. We can see in visualization on the right, we have additional data that you can see. The angle of the spacecraft and height, velocity. Also, the planned line of descent. It's part of the process of testing. You see the yellow dot is the exact location of the spacecraft. First picture is now coming up. The picture was taken while it was landing in an angle. And let's see. This is it, the selfie camera.
So this wonderful selfie picture from an altitude of about 22 kilometers is on the background of the moon as we are approaching the landing site.
I have to underscore, when we planned this mission, we weren't clear that we'll see any pictures during landing, but the communication center in NASA
with JPL communication network, it is possible to bring the pictures online.
We're still landing. It hasn't landed yet.
You are.
Okay, so gentlemen, we are just seeing all of this amazing action right now. Only a few minutes away. Tell us, what can we expect in these very tense next few minutes?
First of all, what's the most exciting is that it sent already a picture.
Certainly.
You can see the craft with the moon in the background. That's unbelievable, really. And you know what? Regardless of if it's going to be a successful landing or not, this is such a huge achievement already that it's unbelievable. But now, you know, let's keep our fingers crossed. It looks like everything is working as planned. So it's just a few minutes away, and the temperature is rising.
And we were talking a little bit about angles before and where it was taking its photo. Explain for our audience a bit more of that.
Yeah. Go ahead.
Yeah, well, the pictures we saw was when the spacecraft was pointing a little bit downwards because it's trying to decelerate, and the camera was pointing along this axis, so looking down. So when it was looking down, it saw the moon in the background, but it saw the limb of the moon. It wasn't looking down towards the moon, but the limb of the moon and the legs of the spacecraft, because it's still pointing that way. When it will finally land, it will land on its own legs, obviously, and then we will see the up close the lunar surface, and from cameras from the side, hopefully we'll see the surroundings.
And how much really margin for error is there in something, you know, like this?
Almost nothing.
Yeah. One thing that was said, and I want to say that because this spacecraft is on the cheap, there's only one of everything. There's no redundancy. So each one of the instruments is designed to work on nominal scenarios and even some off-nominal scenarios. But if any one of these instruments fail, then there's no other navigation, there's no other camera, there's no other engine to back it up. So the fact that there's only one of each is critical.
But that keeps the weight of the spacecraft, of course, very light.
Yeah.
But please note that it had a moment of decision. When it was coming down, the spacecraft could abort the landing if something was not working right, and make another turn and come back in 4 hours. So that was, I was surprised. I didn't know that before, that they have in them a moment of decision.
Okay, and let's go back now to the control room with just a few minutes left until landing.
מה אתה רוצה, שלמה?
The situation doesn't look good at the moment. We are without the main engine. We now see the second picture. We're losing height.
We seem to have a problem with our main engine. We are resetting the spacecraft to try to enable the engine.
האם יש אישור לשלוח אנלוג וג'יי? זה הפעלת מנוע ראשי לפי לחצים. מנוע ראשי עובד כרגע לפי לחצים.
At the moment, the main engine went back to work. We lost a lot of height. Our situation is unclear.
איבדנו תקשורת ב-JPL. היה ריסט שמו.
We are in communication now only from SSE, the supplying company, not with NASA, but we still have communication with the spacecraft. Now we lost it. We don't have any communication at all.
The main engine is back on, but we've lost communication with the spacecraft.
Let's wait for a minute for the evaluations of the control room. We are afraid we did not land in the best way possible. We're now clarifying the situation. At the moment, we have no communication. It may yet be that we lost the aircraft, the spacecraft, and we're looking into it. According to all these signs, unfortunately, apparently we're not going to be the fourth nation in the world. But in any case, this is a great achievement. We were very close to the moon. We are on the moon. We are on the moon, but apparently not the way we want it to be. And we're going to check again and try to understand what happened. Unfortunately, the spacecraft did not come as a whole to the moon. We got to the moon. It's a huge achievement. We are the 7th country that reached the moon. Israel reached the moon.
We had a failure in the spacecraft. We unfortunately have not managed to land successfully. We are the 7th country to orbit the moon and the 4th to reach the moon's surface. And it's a tremendous achievement up to now.
Well, we didn't make it, but we definitely tried. And I think that the achievement of getting to where we got is really tremendous. I think we can be proud.
Friends, Israel is on the moon. I would like to ask the Prime Minister.
If at first you don't succeed, you try again. אנחנו נעשה עוד פעם. הגענו לירח, אבל אנחנו רוצים לנחות יותר
want to land more quietly. That's for the next attempt. But the mere attempt is a huge achievement, and I think you deserve all the applause for that, because we are the 4th country who did it. But we will be also the 4th country that actually lands on the moon. And I think Israel is taking off. Next time, even better. Thank you all. The Prime Minister, ladies and gentlemen, beauty is in the eyes of the beholder. Now we are on the moon with a few parts of the spacecraft. Let's start with that. It's a huge achievement. It's 400,000 kilometers from where we are now. And next time we're going to land softly. You know, in Israel, we got used to do things rigidly. What can we say? It's a tough neighborhood around here. So thank you for coming, Maurice. Thanks to the amazing team. You reached a fantastic achievement.